Hi there. Here we're going to look at new types of graphs, exponential and logarithmic graphs. We're not going to go into too much detail about exponential and logarithmic functions at this point in the course, but there will be a lot more said on that towards the end of the course, usually in the last couple of units. Well, it's important here that the skills that we've learned in sketching the graphs of inverses applies to the graphs of any function. So what I want to do just now is recognise the shape of the graph. And I've just noticed a little typo here up on the grey bit. You can maybe change it in your notes. It should be x is in the set of real numbers. It's just a bit of a typo there. What I want you to do is to recognise what the shape of an exponential graph looks like. I'm sure if you've been watching the news quite recently, to do with the coronavirus spread, you'll see that at the start of the pandemic, this was the shape of the graph in terms of infection rates across the country. We will talk a lot more about what the graph does and looks like later in the course, but recognise that this is a graph of an exponential function. Exponential functions always go through the coordinate 0, 1, and they also go through the coordinate what we call 1a. So for example, if I have the graph of y equals 2 to the power x, then that will always go through 0, 1 and 1, 2. If I have the graph of y equals 3 to the power x, that will go through 0, 1 and 1, 3. 4 to the power x will go through 0, 1 and 1, 4, and so on. So that a value, like we've got here in the grey box, tells us the coordinate that it goes through. So in this example here, I've got the graph of y is equal to 2 to the power x. So it goes through the point 0, 1 and 1, 2. Example 13 is asking us to sketch the graph of the inverse function of that. Now the inverse of an exponential function is called a logarithmic function. So again, don't worry too much about what these terms mean. You'll learn more about these types of functions towards the end of the course. But all I want to do here is I want to take my two coordinates. The coordinates I've got here are 0, 1 and 1, 2. And to do what I do with inverse functions, I'm just going to swap them round. So 0, 1 becomes 1, 0, and 1, 2 becomes 2, 1. And that's really the extent of the knowledge that I need you to know from this. So 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. And that graph is going to look something like this. See, a mirror image that's reflected in the line y equals x. So what I also want you to take from this is, for the future, what exponential and logarithmic graphs, what their properties are. So for an exponential function, it always goes through the point 0, 1. All exponential functions go through 0, 1. They also go through the point 1a. So if the base number in place of a is 4, it would go through 1, 4, or 1, 5, or 1, 6. The graph of a logarithmic function always goes through 1, 0. That's constant for any type of function. But if I replace that a on the base there, say it was log to the base a, or to the base 5 I should say, of x, then it would not just go through 1, 0, it would also go through the point 5, 1, and so on.